lesson 6.1. We're going to talk about angle bisectors and perpendicular bisectors. So a perpendicular bisector by definition is perpendicular and it cuts it in half. So we're talking about the perpendicular bisector of a segment, like going through point P here. Line CP would be the perpendicular bisector because it is perpendicular to AB and it breaks AB in half. So now here's some things that happen when you know a line is a perpendicular bisector. So any point on the perpendicular bisector of a segment will be equidistant from the endpoints. So since C is on the line that bisects AB, C to A and C to B are the same length. And then the converse is true, but any point that is equidistant from the endpoints of a segment, so D to A and D to B are the same, then that means D has to be on whatever line was considered the perpendicular bisector. So let's do a little proof just to look at why this works. So let's say we know that CP is the perpendicular bisector that's given to us. So by definition of perpendicular bisector, we have that they're perpendicular and we have that it was bisected. It's the midpoint. So we're going to say definition of perpendicular bisector. So now here we're saying that the angles formed are right angles, and we're saying that because it was perpendicular, so that's a part of the perpendicular definition of perpendicular. And we always know right angles are congruent to each other by either right angles are congruent or the right angle congruence theorem. We know that AP and BP will be congruent because it was the midpoint, because it was bisected. So that would be definition of midpoint or definition of bisect. CP is congruent to CP. We know that's the reflexive property, anything congruent to itself. So now we're actually able to prove the two triangles are congruent. We see we had these two sides here and the right angle between them. That was SAS. And we know immediately following something like SAS, we would be able to use corresponding parts of congruent triangles are congruent, CPCTC. And if I was able to show that these two segments are congruent, that means C is the same distance from both of those points by definition of congruence. So that is why every time we have a line that is a perpendicular bisector, any point on that line would have created two congruent triangles, making those last sides the same by CPCTC and definition of congruence. So let's find the indicated measures. In the first picture, I see that QS is the perpendicular bisector of RP, meaning S is equidistant from R and P, so RS is 6.8. That's all there is to that. There's nothing extra. In B, I see that FH was perpendicular, and since H was equidistant from E and G, I could say that FH was the bisector. So now I could say that these two pieces are the same, so EF is 9.5 as well, and then the whole length of EG would be 19. And for C, we could see that it's perpendicular and has bisected, making these the same. So I could set 5x equal to 3x plus 14. 2x is 14 and x is 7. So if I wanted to find AD, 5 times 7 is 35. So here are some try problems. You could pause if you'd like. The answers are posted online. All right, example 2, I could see that AB is the perpendicular bisector of segment CD, meaning these two segments are congruent. So x squared plus 23 equals 10x plus 2. This is a quadratic. We have an x squared and an x, so I'm going to get everything to one side and make sure it equals 0. So subtract the 10x and subtract the 2. I'm looking for what multiplies to 21 and adds to negative 10. So I'm multiplying to a positive number, so that's either 2 positives or 2 negatives, and because it adds to the negative, I'm going to go 2 negatives. And then 21 is really 3 times 7, and 3 plus 7 is 10. So that means x would equal 3 and x would equal 7. And now I have to check them. So I always know plugging in a number to square, it's going to make it positive, so I'm going to check it on this side. 3 times 10 is 30, plus 2 is 32, so that works. It's a positive value. 7 times 10 is 70, plus 2 is 72, that works. So actually, both of these were correct solutions. So we include them both in our answer. All right, here's another try. Pause if you'd like. Answers are posted online. So here's our angle bisectors. For an angle bisector, if a point is on the angle bisector, it is equidistant from the sides of the angle. And we know when you talk about a point being equidistant from segments, it has to be the ones that are perpendicular to it. If we don't have those right angles there, I cannot say that these two segments being equal means anything to me. And then if a point is equidistant from the sides of an angle, then that point is on the angle bisector. So let's find each measure. I could see that JG and JH are congruent and perpendicular to the sides, so that means that is on the angle bisector. Both of these angles are 42 degrees, so angle GFJ just equals 42 degrees. Here I could see that the angle was bisected, so since these two segments are perpendicular, they are congruent to each other. So we could say 5x equals 6x minus 5, negative x equals negative 5, and x is 5. So then RS, 30 minus 5, is 25. So there's some try problems for you. Pause now if you'd like. The answers are posted online. For example 4, we could see that the angle was bisected and these two segments are perpendicular to their sides, so they are equal. So let's set them equal to each other. We again have a quadratic with an x squared and an x, so I'm going to get it equal to 0. So I need to multiply two things to get negative 60 and adds to 4. That sounds like a positive 10 and a negative 6. So x would equal negative 10 and x would equal positive 6. So if I try to negative 10, negative 10 squared is 100 plus negative 40 is 60. That works. 6 squared is 36 plus 4 times 6 is 24. 36 plus 24 is 60. That works. So once again, both of them are my solutions. Right? I would have to include both in my answer. Here's another try problem. Pause now if you'd like. Answers are posted online. The last kind of problem we'll do is we are given a set of points and we want to determine if C is on the perpendicular bisector of AB. For that to be true, CA would have to equal CB. And we could tell if two segments are equal by doing their distances. So if I do CA, that's going to be negative 4 minus negative 6, or negative 4 plus 6 squared, and then 3 minus negative 3, or 3 plus 3 squared. So that's 2 squared, which is 4, plus 6 squared, which is 36, square root of 40. And now we'll do that for CB. So we have negative 4 minus 2 squared, and 3 minus 5 squared. So that's negative 6 squared, or 36. That's negative 2 squared, or 4. So this is also equal to the square root of 40. So we can say yes, since CA equals CB. If I got two different values, my answer would be no, since CA does not equal CB. So here's the very last try problem for you. If you wanted to try that out, the answer is posted online. And that is the end of section 6.1.